Okay, hello. This is Kyung of the master's degree in AIMA, and today our member, our master's member, she's going to introduce a 3D instance segmentation, including self-supervised learning. So, shall we start?
Okay, hi everyone. Today we'll present about survey 3D instance segmentation. So first, let me 3D instance segmentation. So the task we will start. We will have input is the call-out. We have NPS. The NPS stands for the number of points, and 6 stands for the coordinate and the feature like RGB. So we will want to assign each point here to the instance ID, like this one is 5 instance. So this is the instance map, and for each instance we will define the semantic level, like which lab the instance belongs to. So C here is stands for the number of labs, and K stands for the number of instances. So the application of 3D segmentation is to have the agent to navigate and make decisions about the 3D surrounding indoor and outdoor. And experiment in 3D segmentation will almost do in the dataset two types. One is indoor. This consists of GANSNet V2 and S3DS. The outdoor is STBL S3D. And the metric we will evaluate by average precision on GANSNet V2 and mean precision in response on S3DS. And the loss for supervise the instance mask is drop into the loss, and depend on the paper, they will provide additional loss like box loss. So about the methods, we will have three main approach, and I will introduce in this present. So the first one is robot-based method. The second will be the clustering-based method, and the final is dynamic convolution-based method. So in each method, I will present one or two main papers. So in the first method, will be the proposal-based method. We will predict the object proposal. Usually, this is the bounding box of the object, and after that, we will refine that object proposal into the instance mask. So, in this object, that have one paper that wrote about this approach is the 3D segmentation instance. 3D segmentic instance segmentation on RGBD scan. It's published in CBR 2019. So this paper will be incorrect, like using both RGB image and the geometry point cloud. Like they will first visualize the point cloud. Like you will divide the space into the rig, and how they combine the RGB image into that voxel. So because the resolution of image is higher than the voxel resolution, so they first apply the 2D convolution. This is the 2D backbone that they present, and they extract the 2D feature, and about the back projection, they will map the 2D feature into that the voxel, the corresponding voxel. So they will get the 3D geometry feature and 3D color feature. So this baseline we have two main ranks. The first rank is 3D detection backbone, and the second is 3D mask backbone. In the 3D detection backbone, they will aggregate the 3D geometry feature and 3D color feature to get proposal bounding box. So how can they define that proposal bounding box? First, they will predict the bounding box objectives and location. The objective and location will be defined like the bounding box coordinates, the bounding box center, and the size of bounding box. And after that, they will use the result of bounding box to get to put into the last classification head to get the last label for that proposal. And after they have the proposal box location and classification result, they will use that and combine with the feature that we get before, put into the 3D mask backbone to get the proposal mask prediction. And like I said before, because they use bounding box, so they need to use additional loss like bounding box loss, which is the regression loss about the bounding box location and the size, bounding box size. But now they don't use this approach anymore because the accuracy of instant map is heavily rely on the quality of 3D bounding box, which can be very unstable due to the significant variance and unseen distribution of 3D point cloud data, and the time to reset the bounding box is very large. So they don't use this approach now. And come to the second approach is the clustering by method. In this one, the method will be learn the feature embedding for each point, and they will use that to clustering point into the group to get the instant mask. So in this method, the first proposed is the dual set point grouping for 3D instance segmentation. This published in CBR 2020. So how they do the clustering by method? First one, they will have the backbone network here. The input will be the color and the coordinate for each point. So the backbone here is the rechaining unit line. This architecture is very similar with unit, but for point cloud. And the purpose of this unit to extract the feature for each point here, and for the feature they get from the backpoint, they will have to bring the first brain is the semantic brain to define the last for each point, and the second brain is the offset brain. So which is the what is the offset? And the offset is the distance from each point here to the corresponding instance centroid. And they contain this semantic result here by the drop entropy loss, and they contain the offset here by A1 regression loss and direction loss with calculated by cosine similarity. And after get the semantic result and offset result, how can we get the instant label? So they will have the clustering path here. In the clustering algorithm, they will use two cluster. Like the first one, they will use the origin coordinate. So from each point, they will iterate over the point here, and in each point they will have like the radius. So you will have like the point have the center is the point we define here, and if any point inside that radius and have the same semantic label, we will assign that one cluster, and they will do that clustering algorithm to the shifted point. The shifted point is the origin coordinate, and we plug with the offset we read it before. So they do in the shifted coordinate, because when if you have the two instances have the same semantic class inside, so it's usually have a failed cluster into the same instance. So they will shift to it and conduct the cluster algorithm to have the better result. And the result cluster, they will do the union in both coordinate and shifted coordinate. And after get the cluster, the M cluster, they will put that into the coordinate. Like in this one, after you get the cluster, you will put that into the coordinate. So the coordinates will be predict the confidence score for each cluster. Like they will postulate for each point inside the cluster, they will postulate it and into the tiny unit and get the confidence score. So this confidence score will be utilized by the non-maximum suppression to get the final instant relation. And but the limitation of this one is the clustering result will be mainly depend on the semantic result here, because for each point you just have one exact class. So if you read the wrong semantic class here, the result of instant will be affected. So to to so this one is the limitation I mentioned before. For the object class in with the brown semantic relation here, they will still have the reasonable score for the true last. So the paper named subgroup of 3D instant segmentation on point cloud will utilize this one. They will grouping on soft semantic score instead of hard relation. The hard relation is this one. For each point, they just have one label, one semantic label. So this one will propose that for each point they will have like more than one, maybe more than one semantic label. And this label is proposed in CBR 2022, and this paper will have the like two main parts. The first one is the bottom up grouping, and second one is the top down refinement. So the bottom up grouping reduce the font-wise semantic label and offset vector. So you see in this bottom up grouping part is very similar to the font group architect here. It also has the unit to inject the semantic label and the offset for each point, and this unit will be retrained first by just only the bottom up, just only by the bottom up part, and after they have the retrain, they will apply to end-to-end to train end-to-end this byte. So how can they do the subgrouping? First, after the input point cloud will be fossilize and put into the unit to get the voxel feature, and they will back project that voxel feature into the point. So they will have the semantic label for each point. This one will be so this point in here, instead of having just one semantic label, they will have n by, so they will have n by c here stand for the last, and this one stand for point. So the pointer is just n plus 1, n by 1, and the offset result is the same with pointer. So how can they do the subgrouping? First one, for each lab, they will have the rest hole for subgrouping, and for each lab in here, they will have the rest hole. This one is the hyperparameter, and beyond the application study, this one is 0.2. So with the last one, they will get the subset here, the subset point n1 that satisfy the last score is about last score is about the threshold, and for each subset point here, they will conduct the clustering algorithm like point group. So each point here can be belong to more than one instance. So by that way you can mitigate the limitation of point group, and they just apply the clustering. They just apply the clustering algorithm to the center shift point to get the offset. So after you get the clustering, this time for the instant reversal here, you will put that into the top down bar. This consists of tiny unit and classification, segmentation, and mask scoring range to get the instant map. So like this one, because of you use the hard prediction semantic score for each point, so they will have like value scale for smart prediction, and by using the subgrouping, you can enhance the quality of the result. So I think this paper is very good because this based on the point group, but just a simple idea to get the very good result. I will show on result in the last. Okay, but like the bounding box approach, they have the limitation because your result will be heavily rely on the clustering quality. So if the clustering quality is not good, the instant result will be not good too. And the clustering quality here is stand for the central resistance. And so, however, this can be very unreliable, particularly when the testing object and the training object is different. Like because in the scannet dataset, they have many sets for the same semantic label, like the chair or the table. So the last method will be the dynamic convolution based method. So what is the dynamic convolution? The dynamic convolution is the convolution that enhance the future representation. Like instead of for the regular convolution, you will have the fixed kernel. So for the dynamic convolution, you will have the kernel that encoding by the input. So like for different input, you will have different kernel. And for this method, the first robot is the Dico 3D. So the robot's instant segmentation of 3D point cloud through the dynamic convolution. This one was published in CDR 2021. And so I think the suitable backbone for indoor instant segmentation will be unit by, because I see many people that use this backbone, use this kind of backbone. So this paper will have like, I think we have two main parts. The first one is the weight generator. This will generate the kernel like I told you before. So for each input, they will have the different kernel, and instant decoder will be the dynamic convolution module. So the first one, they will use the backbone to inject the point-wide feature, like subgroup and for group do before. And how they predict the instant mask. So first they will use the offset and the segmentation head to cluster the point into instant and generate the instant kernel, like use the weight generator to have the kernel. And when you have a kernel, you will use that kernel to the feature that you aggregate here from the mask head to generate the instant mask. So how can they generate a kernel? For the input point down, because you read the offset, you can shift it toward to the corresponding chain joint. So the input point down here will become the cluster here, and after get the shifted point, you will do the cluster algorithm to get the ruptured point, and in ruptured point here, for each rupture you will conduct the convolution to get the kernel. So this, I think the dynamic convolution by method here is very similar to the one-stage approach in 2D object detection, and the clustering based method is similar with the two-stage method in 2D object detection. So I think the one-stage method will be more faster than the two-stage method, and the limitation of this approach, this paper, will be because they only use the appearance feature here for dynamic convolution. So this feature is not distinct enough for separating different instances. And the subgroup, the object is testing and different with the object is setting as different with the training object in the set. So they usually miss grouping. So the first one I will introduce will be enhanced in this limitation. The last one will be the 3D point cloud instant segmentation network with instant aware sampling and box aware dynamic convolution. I think this diagram is clearer than this one. So like I told you before, the dicode 3D just have two main parts. The first one is dynamic convolution, and the second one is the kernel resistance. So after you apply the point, you will have the feature here, the point feature here, and the offset and semantic range you will use for the clustering and kernel generation. After you obtain the kernel for X input, you will use that for dynamic convolution to generate the instant mask. So in this paper, how they can improve the dynamic convolution approach before. So they realized that just using the appearance feature here is not enough. not forget the good result, they will try to utilize the additional data like bounding box, because the bounding box in calculus is very easy to obtain. Like you have the point out here, and you just get the maximum x, y, z, and the minimum x, y, z. You can get the acid aligned bounding box for each instance. So you can use this one to write the additional data for training the instance segmentation. So they will still use the 3D breakpoint to predict the semantic label for each point, the offset for each point, and the bounding box for each point. And they will use that bounding box prediction here. Is the n stand for the number of point, and 6 stand for the max x, y, z, and min x, y, z. So they will enhance the dynamic convolution. I will tell you how they can use the box prediction later. And the second one, they say that the clustering by Trendjoy is not good enough, so they propose the new kernel generator that they name the sampling-based instance Y encoding. And this one will be produce the kernel prediction, the box prediction, and the classification. So this one is the same. The box prediction here is the same. So how they can utilize the bounding box data? I think it's very simple. Like before, you just use the feature mask and convolution with the kernel. So now they just concat the coordinate difference and the box difference here, and conduct the convolution. So they just concat the bounding box relation to here. And about the sampling by instance Y encoder, how can they do that? So they first sample the set of candidate point from initial endpoint, which want to maximize the instant recall rate. This is the purpose to use the instant of sampling. So they try to select the point that not belong to the previous predicted instant map. And so first they will split endpoint here into the small chunk, and in each chunk they will iterative sampling the point that not the background point. They just use the foreground point. So the foreground and background you can decide it based on the semantic class you predict from the breakpoint. And the sampling technique is the farthest point sampling. The farthest point sampling is the technique that the next point that you sample will be the farthest point from the previous point. Like first one you sample this point, and the second point you will get the farthest the farthest distance. From the first point, and the third point you will get the farthest point from the previous point here, 1 and 2. So the third point will be farthest. And they show that the instant recall of different sampling strategy here. And so the number of sampling points will be 2048. So for the instant where farthest sampling point, farthest point sampling, they get the high gig percent for the instant recall. So by this sampling trajectory, they don't miss many instant with very small sampling point. So this one like the downsampling technique from the end point very large number. You can just reduce that point into small number k here, and k maybe stands for 128 point. So I think this one is can be the downsampling technique. And final about the result. So for the result, I report here for the big paper in the three approach, 3 methods. So for the 2 scannet and the S3 DIS dataset. So you will see here the robot space like using the polymorph proposal, and after that refine that polymorph result to get the instant map. This very low result compared to the 2 methods here. And I think now the cluster-based method, the hanging result in the leaderboard is the subgroup and the dynamic convolution by method, the hanging result in the leaderboard is the ISB net that published in CBR 2023. And but the evaluation that I see, because in 2D object detection, you can see that the result for the result for the 2-stage approach will be higher than 1-stage, but 1-stage have the advantage is the 1-stage is very fast, than the 2-stage method. So I think this clustering base can have a better result than the dynamic convolution, which is 1-stage here. So I think in the future will be more research about enhance the result of clustering base. But when I survey, I see that the trending now is the dynamic convolution, because like don't have 2 paper here, but it's not like 4 and 3, 4 and 5 paper about this approach, dynamic convolution base. And moreover, that I don't mention here is you can use the transformer in the 3D point cloud instance segmentation. If you're interested in the transformer by that, I will send you more document about that. But this one is the highest result in the scannet and the H3 now. So if you're interested and want to do the more research in 3D instance segmentation, I recommend that you can read to this page and buy on the state of the art to get the better result. I think transformer approach is the good way, but it's hard to fine-tune the hyperparameter but it's similar to the 2D instance segmentation. So you can buy on 2D instance segmentation and apply the technique into 3D instance segmentation. And this is the reference I use in this design. So thank you. And if you have any questions.
If you are accepting any questions, and if you're in the Zoom, please turn the microphone on. Give us a question. Anyone?
I have questions. Can you go to slide 22?
Okay.
So among these methods, we have backbone like ResNet or transformer use of these methods.
No, I think maybe the robotics can use like ResNet, but now they don't usually use that. I think the two main backbone they usually use in the to process the point cloud is you can use the point nest base backbone and the unit like backbone. This one will use the spec convolution. So in the many methods, I don't see any like ResNet, but because I think that's not very suitable for process the point out. So I just see that two main approaches: the point nest backbone and the unit line backbone. But many 3D paper buy on 2D paper. So if you see that like state of the art in like if you want to read that link from the 2D to 3D, I recommend for 2D you can read the mass to from paper. This one is for 2D segmentation, and they will in 3D that two paper that apply. I think that's not many modified, so you can read this one, the FB former, and R2. This one is very similarity and mass 3D. This one is IEEE 2023 and this one is ICI, and I think this one is very similar by life, but this one is for 3D and this one is for 2D. So this one is transformer based. So if you interested in transformer based, you can read into this one.
Yes, more questions. For those in online, please turn on the microphone and throw the question. And if you're online, feel free to.
For more information, I think now if you can, because the step they have here, the I estimate, they utilize the additional data like the bounding box. So I think bounding box, the bounding box in 3D is have many meaningful like very meaningful data. So you can utilize this kind of data, and if you want to read that this approach, you can buy on the paper. This box too much. I really like this one, but I don't present this one here because this one is one kind of weekly supervised. And I think this one is very simple but many meaningful results. So if you want to utilize the point box, I recommend this paper.
Okay, if you don't have any question, let's get an upload again. And thank you for participating in today's seminar.